Yes, I once again welcome you all of you the lecture series of microprocessors and microcontrollers. Okay, microprocessors and microcontrollers. Now, see, in the last previous two classes, we'll see that. So, what are the different types of the microprocessors? How the microprocessor is working? Different types. Then, what is the basic structure of the microprocessor? And so, once again, you can look at that one. Then we'll go for the next test. Okay. Now, see this. This is the computer. Yes, this is the computer. You can look at this. This is the a small computer. See this computer. So, so now see this a small microcomputer. So in our servers, the entire thing is available. So this is our CPU. So this is our microprocessor because microprocessor is nothing but a CPU on a chip. Microprocessor is nothing but a CPU on a chip. Remember, microprocessor is nothing. Mainly, you are concentrating this one, microprocessor. But when our microprocessor is working efficiently, so we require this some memory. What is the memory? What is the different types of memory? RAM. What is that memory? RAM and ROM. So two types of memories are there. Primary memory. Yes, you know that very well. Primary and secondary. What is the primary memory? Is RAM and ROM are the primary memories. What are the secondary memories? Some hard disk and floppy and CD-ROM are the secondary memories. Okay, we have different types of buses are there. This bus means and connections and connections. We have different types of buses are there. What are the different buses? Data bus, a control bus, and another buses is also there. Address bus. Address bus is there. What are these I/O ports? By using these I/O ports or I/O pins, it has some I/O ports. By using these I/O ports, you are going to interface the input as well as the output events. Okay, so in between the computer and nothing but CPU as well as the input output as well as memory devices, we have some another type of some equipments is also there. That equipments we can call it as our interfacing units, interfacing devices. So we have different types of interfacing devices. 8255 PPA, programmable peripheral interface, or 8279 keyboard interface. Whenever you want to interface the keyboard to that CPU, you require this type of this one. So 8255 PPA, 8259, 8257 is one another there. So different types of this interface devices are there. Okay, we already discussed it. So I modified that this entire structure to like this here. You can see this very well. So this is the CPU. This is CPU, a central processing unit, nothing but ALU. Automatically performs the arithmetic operations, addition, subtractions, multiplications, and divisions. What are the logical operations it can perform? AND operations, OR operations, NOT operations, basically. So not only this one, so you can limit it to the XOR operations, okay, XNOR operations, not so NAND operations, and all are the all NAND logical operations, NAND operations, the NOR operations, okay, like that. You know that this NAND and NOR you can also call it as the inverse circuits. Okay, what are the registers here? A registers is also some type of memory device, some type of memory device, some type of memory devices. So these are basically a flip flops. These are basically a flip flops. Remember, you already studied the flip flops. These are basically a flip flops. So here, different types of registers are available. You know that a 4-bit registers, okay, 8-bit registers, 16-bit register, 32-bit register, 64-bit register, 128-bit registers. You know that you already heard that the system configuration it may be of 64-bit or 32-bit. Last class we are also discussing this one. So whenever the bit size is increases, the speed of that microprocessor also increases. Okay, then what is this timing and control unit? You know that this is timing and control unit. It has the clock. You can also call it as crystal clock. This clock, so whenever you want to buy the some microprocessor, on the time you can see the 2.0 gigahertz clock, some 3.0 gigahertz clock, or 3.2 gigahertz, or like that. Okay, whenever you remember, the entire speed of the microprocessor is dependent upon this, the entire speed. So the clock speed of this microprocessor. So, it's nothing but this timing and control unit. You can also call it as a heart of the computer. Heart of the computer. You know that this ALU, you can call it as a ALU, and registers you can call it as the some brain of the computer. Brain you can also call it as a brain, but this timing and control unit you can call it as a heart of the computer. Okay, however, for suppose we can consider it as some human body. However, our brain is nothing but our brain is working like that. It can calculate something, or it can think something, or it can store the memory, or like that. You can call it as some brain of that memory. You can simply say that. So this timing and control is nothing but heart. However, heart is pumping each and every organism that is present in our body uh, to control that one. So likewise, so this timing and control unit is connected to the each and every part of the microprocessor, automatic CPU. At the same time, outer side of the device also to control this one. How it is controlled? How it is controlled? By means of how it is controlled. So in our heart is pumping some blood, like our consider our human body. Heart is pumping some blood to control it. Nothing but some alive that. But here, the timing and control unit is sending some clocks to control the number of clocks to control the. How these clocks? These are how many clocks? For suppose we can store the memory. You can store the memory, or you can retrieve the memory, or you can connect the some keyboard, or you can disconnect it one. You can connect it one, or you can disconnect it one, or you can connect this some mouse, or disconnect it one, or you can connect the keyboard, or you can press the some keys to the keyboard. How this all the things is controlled by this control this timing and control. So how many clocks? So some for suppose we can connect this some RAM and ROM. RAM and ROM. The speed of the RAM and ROM is very slow when compared to the CPU. You know that very well, because we are connecting some USB pen drive. You can think that's a pen drive. So that pen drive speed is always less than the CPU sometimes. Okay, so how this will be active and alive? Nothing but alive means how this input output devices is connected to this class. How this how these are uh, operated. So these all the things are operated by timing and control unit. You can simply sense the some clocks to control that devices within that microprocessor. Yes, within that microprocessor. Okay, the same time outer side of the devices. How many clocks? How many clocks it will send? So different operations it can send the different fixed, remember, different fixed number of clocks. For suppose you can store the memory to the RAM, you can send this a fixed number of clocks. Or for suppose you can whatever the information present in the memory is copied to that CPU. Okay, it can perform the some different a fixed number of clocks. So these are fixed, okay, not the variable. These are it can send the signals to this input output device, or within the ALU or registers to the a fixed number of flags to control the this device. This is the operation of the timing and control. Okay, then what is this interfacing unit? Interfacing unit, we have some pins. You know that we have different types of pins. In our 8085 microprocessor 086 microprocessor we have 40 pins. As I said in the earlier, if the number of pins of the microprocessor is increases, the cost of the microprocessor is increases. At the same time, the performance is also increases. I said why? Why that performance is increases? So for the pin diagram, I will explain in depth to this. Why that performance is increases. If you increase the pins, why the performance of the microprocessor increases. In the pin diagram, you have some pin diagram concept. So we'll discuss it in, on the chat and on the topic. Okay. So this interfacing, you have some pins. By using this interface, nothing but for suppose you can think that in our computer or laptop or whatever it may be, we have some USB ports, HDMI ports, okay, then power socket and power connector, all the things where you can connect it. This one, all these are connected by using this interfacing or by using this interface. Okay, so as I said in the last classes, so this memory as well as input output devices speed is very less when compared to the CPU. It will not matching the CPU. So it has some power conflict problems is also available are arising into whenever we are connected to the input output device to the CPU, or some speed issues there, some compatibility issues there. You can solve all the things at the same time. You can button the you can reduces the burden of the microprocessor. You can use this of interfacing devices. In between the input output devices as well as the CPU, we are using some interfacing devices 8255, then 82, then at the same time 8279 and 8257, so in different 5 different types of interfacing devices. Then what is a bus? A bus is a number of wires, connecting wires to connect to the each and every uh, a component in the microprocessor at the same time outside of the microprocessor. So any information is sending our clocks, including clocks, or any information is sent to this one, or we can receive this one from this buses only. That's why we can divide this buses into the different types, 3 different types. Address, I will tell you what is that address, as well as data, as well as some control bus. So different types of buses we are dividing buses. Buses mean nothing but a simple connectors, a connecting wires. Simple. Okay. So this is the basic structure of the mechanism. I think last class we already discussed all the things. Okay. Once again, you can see this input devices, some keyboard and some source data, speeches, some mouses, some touch screen, all other things you can consider as input devices. What are the some memory? As I said, we have different types of memories are there. Yes, this is the hierarchy of the memory. You can call it as hierarchy of the memory. You have this registers and as well as the primary memory as well as the secondary memory, and the next one is the external memory. So in between this one we have some cache memory. Cache memory is also cache memory. So the registers, now you can see this. I mean, uh, the first is connected microprocessor accessing. Nothing but this is accessing. First registers is accessing the first registers is accessed by the microprocessor. Then after the primary, then after the secondary, then after the fourth. So what is the whenever it comes down, the size, nothing but memory size is increases. Memory size is increases. Always when compared to the registers, primary memory size is more. Okay, when compared to the primary memory, secondary memory size is more. When compared to the secondary memory, external memory size may be more. So this is the hierarchy. This memory. This is the memory hierarchy. You can call it as memory hierarchy structure. Okay, microprocessor is first accessed by the registers. As I said, registers is also some memory. So it has a 4 bit, 8 bit, 16 bit, 32 bit. This is also the memory. 16 bit or 128 bit. This also you can call it as a memory. So then at the same time, primary memory you have primary memory, RAM and ROM. What is the secondary memory you have? What are the different types of secondary memories we have? Some CD-ROM, some hard disk. Especially here we are discussing the hard disk. Hard disk. What are the some external memories? CD-ROM, some external hard disk, etc. You have different types of memories. Okay. So these are the secondary memories. You know that some magnetic tape and all this. And what are the output devices? Some monitors, printers, and some microfilms are the output devices. Yes, oh, you can see this. Then evaluation of the evaluation, nothing but the where that microprocessor is developed and all. You know that a microprocessor, a first microprocessor is developed by the Intel. Nothing but so whatever you are discussing the entire thing, there may be of 8086 microprocessor, okay, 8086 microprocessor, 8086 or 8051 microprocessor. This is microcontrollers or PIC 18 microcontrollers are interfacing devices 8255, 8279, 8257 all are developed by the Intel. Okay, you are studying the Intel manufactured devices only. You just study, remember, you just study and you just remember all the things. Okay, because these are already developed. Okay, this is not the large scale subject to apply the some calculations and do the some work. Okay, you just study because these are all developed. Okay, you just study how that is working. Okay, what is the internal parts of the microprocessor. Okay, and all. Okay, this nothing but some working principle and working separate. So you see this microprocessor. A first microprocessor is 4004 microprocessor. A 4-bit microprocessor. A 4004, a 4-bit microprocessor. As I said, whenever you increase the size of the microprocessor, a bit size is nothing but the a registered bit size. Nothing but the a registered bit size. Okay, registers are nothing but the what is the registers? Registers are nothing but the what it mean? A flip flops are simply a flip flops. I tell you what is the use of the registers in the CPU. As you know that ALU is the uh, one function of nothing but it can perform the arithmetical and logical operations. You require the ALU. Okay, then you know the timing and control unit. Why the timing and control unit? So it can perform the it has generated some clocks to control the each and every part in the microprocessor at the same time outer side of the connected device, nothing but memory and input output device. And what is the functionality of that registers? I will tell you. Okay, in the next slide, maybe one or two slides, I will tell you why the necessity of the microprocessor. What is the use of the the registers that is available in the micro? You see this? Yes, we mentioned the registers. You see this? We mentioned the registers here. Yeah, you can look at this. You see this registers. What is the advantage of this registers? Why the registers is needed in the microprocessor? Yes, you will see it in next slides. Okay, so this is a 4-bit registers. Then what is the clock speed? You know that clock speed. You see this clock speed. Yeah, as I said, the entire speed of the microprocessor is dependent upon this clock speed. First thing. Okay, then second category is given to the this one. This is the first preference. This is given to the second preference. I want to say that the speed, but as I said, if the pins is increases, the performance, robustness is also increases. I'll tell you that why that is in the bit. Okay, so the entire speed, whenever the speed of the micro was nothing but 3.2 gigahertz, 4 gigahertz, like that, you remember. So, but in the early days, so the first microprocessor is 4004 microprocessor developed by the Intel. So it is a 4-bit microprocessor. The clock speed is 740 kilohertz. 740 kilohertz. That is so in the invented year 1971. The first microprocessor is the Intel. Remember Intel. Intel developed microprocessor. All these are microprocessor evolution by Intel. Intel Corporation. Remember Intel Corporation. Intel Corporation. So this is the first invented in the year 1971. So next invented the 8008 microprocessor. That is the 8-bit microprocessor. If that clock is that mm, clock speed is you see this nearly of 500 kilohertz. Okay, invented in the year 1972. Next that one is 8080. 8-bit microprocessor, 2 megahertz clock it is. Okay, in the year 1974. So next one is 8085 microprocessor. That one. This one. So this is our microprocessor. We are studying. This is our microprocessor. So 8086 microprocessor invented in the year 1978. So this is the some evolution of the microprocessor. So now see this. Some i3, i7, i5 and i7 you are using. These are the 64-bit as well as 128 bits is also good. So these are 2.4 gigahertz, 3.6 gigahertz, okay, 2.0 gigahertz, okay, 3.2 gigahertz. Different speeds are available. So invented in the year 2010. You know that so we have we are under 20%. We'll see that one in the 20 in the year 2020. So 11 years gap is there. So you know that we have different types of generations are there. Right, three first generation, right, first generation, second generation, third generation, fourth. Where they are running, I think 11th generation. Okay. Now these are the some evolution of the domain. So now see some small basic some small basic features of this microprocessor. So it is a 16-bit microprocessor. Or 8086 microprocessor is how many bits is here? It is a 16-bit. Why it has 16-bit or 8-bit or 4-bit? You can see it in next slide. How we will decide that it is 16-bit microprocessor? Why it is not the 8-bit microprocessor or 32-bit microprocessor? Why only it is a 16-bit microprocessor? How this bit size is decided? Okay, so it has 16-bit data bus as well as some address bus to read and write the memory. Read and write is nothing but the write means here you can send the information. See, you can send the information. And read means you can copy the information. Copy. You know that copy and paste. You know that copy and paste. So read means a copy. Yeah? And write means you can send the information. Okay, remember. Read means you can copy. Read means a copy. Write means a send information. Send. Remember. Send. So it has 20-bit address bus. It has 20-bit address bus and can access up to the so 1 MB memory. Remember, you can access up to the 1 MB memory. We will see all the things. Remember, just see the features. Why it is 1 MB? Why it is for 16-bit MB? I will tell you everything. Okay, so it has it can support up to the 64K size of the input output devices. Remember, so when you are connected to the RAM and the ROM, okay, some input and output device, some memory device. Which size of memory devices you are able to connect to that microprocessor? It has only 64 kilobyte. Remember, now you are using pen drives or USB size is of about the some in terabytes only. But on the 1978, our microprocessor 8086 microprocessor 8086 microprocessor, you are able to connect the memory devices. The size is input output devices. Input output devices. Nothing input output device. What are the input output devices? So here you are not considering the RAM and ROM here. I will consider the. I mean, this is the RAM and ROM memory. This is RAM. Sorry, this is the RAM and ROM. This is the input output device. What are the input output? Some keyboard, some mouse, some USBs, etc. 1 terabyte, etc. 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 That size is only 64 KB. I tell you why it is only 64 KB. Why it is RAM and ROM memory is 1 MB. Okay, I will tell you. Okay, so it can provide 16-bit address registers. It can provide 14-bit and as well as preferably we will read the 16-bit. Is not okay 16-bit registers. So it has the multiplexed address and data buses. Multiplexed address and data buses. You can see everything. It requires single phase clock 30% duty cycle to provide the increment time. Okay, so this one is also important. This all the features, 9 features are very important. This is a 16-bit instruction byte. Remember, it has the sorry 6-bit, 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 6-byte, 6-byte instruction. It has the 6-byte instruction. Why? Why it is only the 6-byte instruction? I tell you why. So these are the so this 8086 microprocessor operated in two mode, minimum mode as well as the maximum. Okay, this all the things, most of the things here mentioned is mainly depends upon the resistors. So the first one is the 16-bit resistor. I tell you why you can see this resistor. So the resistors. So we'll divide into the two types: general purpose resistors as well as the special purpose resistors. Okay, general purpose resistors as well as the uh, okay special purpose resistors. Okay, at the same time this general purpose registers as well as special purpose registers we can subdivide into the general data registers, segment registers, pointers and index registers, and flag registers. See this how many different types of registers. What is this register? A register is nothing but a simple memory device. A simple memory device. These are responsible for, remember, responsible for the size of the program and the size of the instruction byte. Instruction byte. Okay, okay. This is just responsible. A primary operations. Whenever microprocessor is performing, for suppose you can write the programming is as you see that move a comma b some. So this is the language we are using. Assembly language move. So for suppose move suppose write the programming is like this: move some a comma 10, move some a to b, something some b to a, or whatever it may be, b to a, then again move a comma 20. So I write the and a comma b. I write for suppose. So what is the answer for this one is the result is 30. First of all, I just write this small simple program. For it has some instruction mistakes is also available, but for your easy understanding purpose, I write that like this. So the result is that whenever the information is available in the registers, this A, B, all the registers. Well, simply I can send the some 10 value to the A register, then A to the B register, then 20 value to the A register. I can add the A and B. A is the 20 now, and B is the 10. The total result is 30. Whenever microprocessors perform this type of operations, okay, whenever that information is available in the registers, so the information is executed. Nothing but the instructions is executed within that registers. Okay, within the registers. So that's why registers are very much essential. That one. Without these registers, you are unable to write the program. The size of the program is decided by these registers only. Whenever you want to write any of the program, so first it will be going to the registers, and then after the so this is a very essential for the registers. Again, why it is 16-bit and 8-bit registers, 30-bit registers? On that time, you see this, this on the time 2010 and the time it has only a 64-bit registers. Now it is available in the 128-bit registers because so many factors. The main thing is the size, and next one is the cost. If the number of bits is increases, the cost is also increases. Okay, okay, this is the register. Okay, we have different types of registers is available. I said, why? You see this? So these 2 points are satisfied. These 2 points are satisfied. Now, what is this third point? It has 20-bit address length. This memory is 1 MB. So remember, whenever anyone asks me that what is the memory size of the microprocessor, anyone asks that it is a 1 MB memory size. Okay, what is the how many number of bits of 8086 microprocessor? You said that it is a 16-bit microprocessor. So what is the size of the input output ports you are going to connect this 8086 microprocessor? That is the only 64 KB memory size device we are going to connect. Okay, why it is 1 MB memory? Why not it is more? You see this. Come back to this one, this diagram. You can see this diagram. Yes, you can see this diagram. So this memory size is how much? 1 MB. Yes, 1 MB. Remember 1 MB. You know that 8086 memory size is how much? You know that nowadays we are going to purchase the cell that may be of 8 GB RAM or 4 GB RAM. That memory size is 64 GB or 128 GB. Nowadays we are going to see that a cell phone's at least memory size is 32 GB. Is very rare cases. Now most of the people is buying this one, the 4 GB RAM, okay, or 8 GB RAM. The memory size is 64 GB or 128 GB. Now we can see the memory size of the microprocessor is only 1 MB only. Why it is only 1 MB? Why not this 128 GB, 64 GB? Yeah, there are so many factors out there. Why it is not increasing the price? Because first one is the technology. You know that on the time they are using the solid state technology because by manufacturing this devices. So nothing memory device is somewhat bit quite costly at the same time. The size means here the physical appearance of that memory is also very large, big size. So that's why. So there are some distinctions. Why it is only 1 MB means here. So our microprocessor is interfacing, as I said, in between the CPU as well as in output input output device, we are connected the bus and that would number of, as I said, what is that? Number of lines. Number of lines. There are different types of buses is there. Address, data, as well as the control. Different types of buses. Address bus, data bus, as well as control bus. So, what is the size of this address bus here? A 20-bit address. What is the data? Is here a 16-bit data. It's 16 lines. Mathematics 20-bit means here. So these are the pins. These are the pins. So each and every line we have the one address. So 20 out of 20 pins, how many pins are used for the address is 20 pins. So out of 40, remember minus 20 bits are used for the address. Again minus 20, 16 bits are used for the data. And remaining how many bits are remaining is you know that 36 bits are you can see it's only 4 bits are available. 4 pins are available out of that 40. So one pin will indicate one bit. So nothing but 16, 20 pins are replaced this one. 20 pins. The 16 means that 16 pins are replaced this one to connect the memory devices. You can understand this one? You can understand this one? Okay. So that's why we have, as I said, so the size we will discuss it in size. A 20-bit, a 20-bit represent. You can also increase the more than this 20 lines, but where are the number of pins? Where are the pins is available? The pins are not available. When increase the 25 pins or 30 pins, so it is not available to accommodate this one. As I said, that's why the performance of the microprocessor depends upon this number of pins. I said, okay. So that's why on the time they are restricted to the 20 address lines. So nothing but you can calculate the 2 power 20. So it's nothing but nearly 1 MB size. Nearly 1 MB size. Nearly 1 MB. 2 power 20. Then data lines. Why the input output devices is only of 64K? Nothing but number of data lines 2 power 16 is equal to nearly of 64K. This is the reason. So that memory nothing but RAM and ROM. A combined memory. Remember, RAM and ROM combined memory is 1 MB. RAM and ROM combined memory is 1 MB only. So nothing, how this 1 MB is divided? So R part is divided by 1 MB. This is 1 MB memory. R part is divided by the RAM. And then another R part is occupied by the ROM. 50-50 share. Okay. 2 power 20 is equal to 1. 2 power 16 is equal to 64. You understand why importance of the pin? Importance of the pin. You know that. But you see this 20 bits are assigned for the addresses to memory devices. Again 20 bits are again 16 bits are given to the data bus. What is data bus? Then remaining only 4 bits. To avoid this one, we can utilize the one pin for more activity purposes, because we have only 40 pins. So that's why this address and data pins, they are uh, used for same pins are used for the both purpose, addresses and data purposes. So that's why only 20 pins are available to use the address as well as data. So you can reduce the 16 bits. Okay, so that's why they are invented something here. So that's why some devices, some multiplex devices. So that why this address and data bus is called as a multiplex lines. The multiplex lines, bidirectional, but it can send the information, at the same it can receive the information. So bidirectional multiplex lines, bidirectional multiplex lines. But multiplex means here the same lines, the same 20 lines you can uh, utilize it for the both the purposes. Okay, both purposes are nothing but the uh, what is that one? Both purposes nothing but the like data as well as the address. Okay, so this is the important of the pins. You know that. Okay, so so we have different types of registers are there. So we will discuss it in the last class. Okay, thank you. Thank you for joining the class today.